Welcome back. Let me start the foundation of inheritance. Let's say there are two classes. One is, we call it a base class, and one is a derived class. The class which is inheriting another class is called derived class. And the class which is being inherited is called the base class. So for example, if there's a class A and class B, if the B is inheriting A will be called base class, B will be called derived class. In that concept, I have used MFIN and advanced MFIN. If MFIN has resources, we call it, or you can simply say variables and methods, there could be some other things also, but let's focus on variable or method. Any variable or method which is in public or internal in nature of access, that will be available for FINs. To understand this with an example, I'll probably give you an example here. Just have some. All right. You can probably focus into these two. You have basic FINs having variables v1, v2, method m1, m2, m3. And I have inherited it here by this colon and writing the base class name. If I make an object of advanced FINs, what will be available to the object? Will it be v1 available here, v2 available here, m1 available here, m2 available here, m3 available here? Of course, it is a small m. Which one will be available? My understanding is it will only have the availability of whatever is public or in internal. So private, it will not be available. Private, it will not be available. Only the public ones will be available. If you make the object, maybe like this. Here we have made an object. And if I try to say advance Fink dot v1, yes, it will be available to us. If I say v2, no, it will not access. m1 not accessible. m1 accessible, m2 accessible, m3 not accessible. Let me see that in the code itself. Where we are ready with the same code, I'll try to here directly and say advance Fink dot. You can see if I write v1, yes, it is available to us. But if I try to say v2, see the error is not accessible. You can naturally say it is not available. So it's not part of the child. It's only part of the parent, because it is, though it is written into the base class, but accessibility is private. Even with the case of internal, you would see the same problem. Sorry, internal will be available, public or internal, but whatever is private will not be available. So with internal also, you can see it is available. But the moment I write it private, whether you write public or internal doesn't matter. But if I write private, it won't be available. With private, it is not available, not accessible. Public, accessible. Internal, available. Right? Since we little bit goofed in, so if it is public, it is available. If it is private, not available. If it is internal, available. So public internal is treated as same for you. Whatever is accessible, you can say, outside the class limit will be available into the inherited class. That's number one. So I can write it here, whatever is accessible first, which will help us. V2 is accessible. I can even try to check other ones. M1 is available. M2 should be available. Only these are available. Private ones are not available. Right? For understanding, if you want more clarity, I'll create one more variable here. And this internal public is same for variable as well as methods. So here also one I'll make internal. Pretty decent. All are these are not available. So whatever is not available, we can go ahead and quickly do that. They are not available. All these are available. All right. Whatever is not available, I've written it so that you understand, and I'll make them commented. Sorry. Now, if I make anything further as an addition, for example, int var semicolon, and definitely I'm making it internal public, doesn't matter to me right now. Now see what happens. It is available in the advance. It is available. So whatever is available in parent as a public one is available here, as well as local, whatever was there is also available. All right. Now the question comes is, if it is available to child, will the same thing will be available to parent? The one way would be make an object of parent and see if it is available to you. So let me make an object of and try to say, is it available? No. The child, whatever data is in only in child, whatever it is in the parent, it is not at all available. So why don't we take this as a diagram and take for understanding. I'll keep this in the side. This would probably help us to have see them side by side, right? Let's take this for understanding. Same concept will help between parent and child. There's nothing new here. Yes, this is going to be our base class. And this is our derived class using this way. This is the class, this is the base. You can see very well, advanced has the access of things which is there in base. V1, it is there in base, accessible. V2, accessible. V3, it is private, though it is there, not accessible. M1, which is there in base and accessible with public, so it is there into child. M2, but M3 not available. On top of it, we created one variable which is there only in the child. So what is there in the child? Can it be accessible to parent? No, the reverse is not possible. So if you see, if you make an object of base func and try to access var, not possible. Now, it's not that you have to make the object every time to access. In some cases, we do this following. Please see here. Maybe I have, since you all understand that directly into a class, you cannot do assignment works. You create a normal method or something. Just for understanding, I'm creating a method called dumb meth. I'll just go here and try to access what is there in the child. So child class resources can be accessed in the, base parent class informations, resources, variable methods can be accessed into the child class via a method in the child class also. So here I can say v1 equal to 20. You can do this as well. This is allowed. Likewise, v2 equal to by. But if I try to do v3, I doubt that we can do that. And of course, the same error it will say not accessible, right? And same goes. If I try to access M2, yes, we can. M1, we can. But if I try to access M3, I doubt that we can. So you need to understand that accessibility doesn't mean always creating an object. All right. So this much, we are on the same page. Now this next thing comes up is, what if, pay attention please, there's a resource into the child. For example, let's say, for a better understanding, I create one method call here, which is internal int add, which adds to number and returns the sum. All right. So definitely, one thing is for sure, you can call it via the object because it is there into the parent, so the child also must have it. We can understand that. You have an add. No problem. Because it is there into the parent, it is. Now, someone further makes the another implementation into the child where only internally something is different. Some implementation, doesn't matter. The implementation is not a problem here. So to hide the implementation, I'm going to quickly do this because our focus is the signature here. Now you tell me, when I have called advanced func.add, now this add is there into its local as well as into the parent. Which among these two it will call? And by now you would have realized it is acceptable to reuse the name with exact signature. This is the only place where you can do. Reuse the name with the exact same signature into the inherited class. That's the only place where you can reuse the same signature. And if that is the case, which one will be called? In general, I will tell you, because we have to go into detail in which case which one will be called. But in general, you can say it will call the local. Local means wherever it has been defined. If the child, which is the object here, so whichever object is running, the running object is advanced func. So whatever is in the advanced func, that will be called. So if you do advanced func.add 30, 20, well, whatever is the logic, it will give you 30 plus 20 by 2, which is 40. All right. It will call this one instead of calling the up one. Now, for the simplicity of running, I'll just put a breakpoint here with no, I just want to, because we would have done a lot of accessibility issues. So I'll just put that as a comment and rerun it. Yeah. So I want to let you focus here and see where it will go. Will it will go here or will it go here? Which one it will go to? Guess and tell me. Which one it will go to? Child or parent? I think it will go to child. See, it has got to child. In the case where two names are available to it, it goes to child, which is what we started with as a puzzle. Everything else is probably understood to you. There's nothing much to discuss. The next clippings, we have to go ahead and understand exactly how, what is this called? This phenomena when exact same name with the exact signature is there available in two places. That's called method overriding conceptually. This is the case when you override only the body. That's the only place where they differ. However, doesn't matter, you could have kept the same body, doesn't matter. But you are able to override by child. So that's actually the beginning of overriding. Quickly, I want to add one more thing. Sir, is it possible to make overriding across the classes? So this one is called overriding. Yes, we can do across the classes. But in the case of inheritance, as we know, overloading earlier, just to point you out. So first I will call it, this is a concept of overriding. But I want you to remind, if you just do this, this is a phenomena among these two. It is called overloading. When signatures are different, okay, this is called overloading. When you have the signature different in the same class. The question comes here is, can overloading be done across classes? Yes, gentlemen. Instead of keeping here, it is allowed to have overloading here. There's no problem. Okay. So overloading across classes and same class allowed. Overriding is allowed only across the inherited classes. That's it. All right. So overloading can be there. So what you can do is you quickly make one more class here. All right. And I'll keep one more. Yeah. I'll hide whatever is right now not required. so that you can take a right picture here. Region and region, collapse it. Super. We just need only these. Let us focus only this part of the code to understand which is what. In the given code, I'll just make a picture over here for your understanding. You can understand this and this are exact same name, same signature among this. I can call it sample X, sample X. They're exact same. So exact same across classes of inheritance only allowed. Across class it is allowed. Whereas overloading, where signature differs, it is allowed in the same class as well as allowed across the class. Okay. So overloading allowed in same class as well as across. Overriding only across. So you can, if this is confusing, just remember in the same class, some differences are required. Some way it has to differ in the same class. Yes, they differ. In the same class, they do differ. Across the classes, they can be same. That's it. So try to understand this and do this question or some other question, some practice which I'll upload, and then probably we will continue to the real concept further. Thank you very much, all of you.